We're going to be looking at a motion problem. We're told that the Columbia River flows at a rate of 2 miles an hour for the length of a popular boating route. In order for a motorized dinghy to travel 3 miles upriver and then return in a total of 4 hours, how fast must the boat be able to travel in still water? As part of the familiarize step, especially in a motion problem, it's good to read the problem again carefully and look for the 2 or however many there are different situations of motion that we're looking at here. We are looking at an upriver motion and then a return, which would be downriver. Recall that the speed of a boat upriver is its speed in still water minus the current. Downriver is its speed in still water plus the current speed. Since we are dealing with distance, rate, and time in motion problems, we need to talk about distance. The distance is not given, but there is something very significant said about the distance. This dinghy travels upriver and then returns. That's a clue that the distances we're looking at are the same, whatever they are. And we're given time. We're told that the distance is 3 miles, so the distance is 3 miles both upriver and downriver, so we do know that. And we're given the time of a total of 4 hours. So we're not given the individual time, so we're given the total. So we don't know the rate of the boat, but we know the rate of the current. We know the distances are both 3 miles, and we know the total time is 4 hours. So since we're asked how fast the boat must be able to travel in still water, let's let R equal the speed of the boat in still water. And we'll let T equal the time of the trip upriver. Now we're defined 2 variables. We'll have to work till we get an equation of just 1 variable, but we can do that. If T is the time of the trip upriver and was 4 hours total, then 4 minus T will be the time of the trip downriver. Now we have 2 motion situations, upriver and downriver, and these become the rows of the table that we set up. We're dealing with distance, rate, and time, so those become the columns of the table we set up. And let's fill in as much as we can with what we have of these entries in the table. The distance upriver and downriver is both 3 miles. The speed of the boat upriver is the speed of the boat in still water minus the current, which was 2 miles an hour. So that would be R minus 2. The speed or rate of the boat's travel downriver would be R plus 2. The time of the trip upriver is T. The time of the trip downriver is 4 minus T. So when we translate the problem to equations, we can translate by using distance equals rate times time. Or in this case, I'm going to use time equals distance divided by rate, because the times are related with addition. One is T and one's 4 minus T. And we're going to be able to solve that way. So I have, first of all, that the upriver time, T, is the upriver distance divided by the upriver rate. The downriver time, 4 minus T, is the downriver distance divided by the downriver rate. These both have to be true, and I'm going to substitute in the next step to solve. Since T equals 3 over R minus 2, I'll substitute that for T in the second equation and then solve for R. I have 4 minus T, or 3 over R minus 2, equals 3 over R plus 2. Multiplying on both sides of the equation by the least common multiple of the denominators, which is R minus 2 times R plus 2, I have R minus 2 times R plus 2 times the left side of the equation, which is 4 minus 3 over r minus 2, equals r minus 2 times r plus 2 times the right side of the equation, which is 3 over r plus 2. Now when I multiply using the distributive property, I have 4 times r minus 2 times r plus 2 minus r minus 2 times r plus 2 times 3 over r minus 2, which is 3 times r plus 2. And that equals r minus 2 times r plus 2 times 3 over r plus 2, which simplifies to 3 times r minus 2. I can now multiply r minus 2 times r plus 2 to get r squared minus 4. I multiply here and I get minus 3r minus 6. And finally multiplying, I have 3r minus 6. I need to do one more multiplication in order to remove these parentheses. I have 4r squared minus 16 minus 3r minus 6 equals 3r minus 6. I have a quadratic equation, so I'm going to collect all the like terms on, or all the terms on the left side of the equation to get a 0 on the right side of the equation. I can, first of all, I notice I have minus 6 minus 6. I'm going to add 6 to both sides. That gives me 4r squared minus 16 minus 3r equals 3r. Then I'm going to subtract 3r from both sides. I have 4r squared minus 16 minus 6r equals 0. And I'm going to rewrite this in descending order. 4r squared minus 6r minus 16 equals 0. I notice that I have a common factor here of 2. Just to keep the numbers a little smaller, I'm going to divide every term by 2. And I'll divide 0 by 2 as well. I'll divide both sides of the equation by 2. So I have 2r squared minus 3r minus 8 equals 0. This doesn't factor. I need to solve it using the quadratic formula, where I have a is 2, b is negative 3, and c is negative 8 from this quadratic equation here. So my variable r equals, I'm going to say the quadratic formula and substitute as I go. R equals the opposite of b, so it's the opposite of negative 3, plus or minus the square root of b squared, that's negative 3 squared, minus 4 times a times c, substituting as I go, all over 2 times a, and a is 2. Simplifying, I get r equals the opposite of negative 3 is 3, 3 plus or minus, and now I have 9, the square root of 9 plus 4 times 2 times negative 8 is negative 64, minus negative 64 is plus 64, all over 4. And I can simplify a little further. That is 3 plus or minus the square root of 73 over 4. Approximating using a calculator, I would approximate 3 plus the square root of 73 over 4, and then 3 minus the square root of 73 over 4. And I get that r is approximately 2.89, that's using the plus, or r is approximately 1.39.